In 1859, communications buildings all over Europe and America began to catch fire. Wires glowed with blue fire right in the night air. People who worked with the equipment were getting electric shocks, even though the power was turned off. This went on for 17 hours, after which everything stopped as suddenly as it had started, as if nothing had happened. Hello, my friend. You're on the Kurtop channel. Today we'll look at 10 natural phenomena, each of which has already nearly wiped out human civilization once, and each of which could do it again at any moment. Not over centuries, not over decades, but in just 24 hours. The most dangerous one is the last on our list. It doesn't explode or burn, it just quietly changes right now. And most people on the planet have no idea about it. Watch the video until the end. Antibiotics no longer work. In 2019, the WHO published a report stating that bacterial resistance to antibiotics is one of the most serious threats to human health. Not terrorism, not nuclear weapons, not asteroids, but bacterial resistance to antibiotics. At that time, about 700,000 people died each year from infections that could not be treated. That's more than from malaria and more than from diabetes. If you've ever taken antibiotics, and most people have, here's what happens inside. The antibiotic kills most of the bacteria that cause the infection, but not all of them. Those that survived have something that helped them withstand it. A small genetic difference. They reproduce and pass this difference on to their offspring. After a few generations of bacteria, and for them, a generation is just 20 minutes, the population becomes resistant. The antibiotic no longer works. Alexander Fleming, who discovered penicillin in 1928 and received the Nobel Prize for it, warned about this very thing in his Nobel speech. He literally said that an ignorant person who doesn't finish their treatment and gives bacteria a chance to develop resistance bears moral responsibility for the deaths of those who later catch the infection from that person. That was in 1945. Since then, we've used antibiotics in livestock on an industrial scale, given them for viral infections where they don't work at all, and failed to finish treatments exactly as he warned. Now, there are bacteria in the world that are resistant to all known antibiotics, without exception. Not most of them, but all of them. Doctors call them superbugs, and the first cases of infection with them have been recorded in every country in the world. So far, there are relatively few such cases, and most people don't encounter them, but the number is growing every year. To understand how much this changes medicine, think about this. Heart surgery, organ transplants, cancer chemotherapy, complicated childbirth. All of this is only possible because after surgery, people are given antibiotics that prevent bacteria from taking advantage of the situation while the immune system is weakened. Take away antibiotics, and most of these procedures will become so dangerous that doctors will simply stop doing them. We would return to a world where a scratch from a rusty nail could kill a person. That's exactly the kind of world everyone lived in until the 1940s. Hardly any new antibiotics are being developed. Pharmaceutical companies don't find it profitable because antibiotics are taken for a 10-day course, not for a lifetime, like blood pressure pills. The last fundamentally new class of antibiotics was discovered in the 1980s. Since then, nothing. Bacteria evolve quickly. Humanity is slow to find a replacement, and the gap between them grows every year. The Carrington event. On September 1, 1859, British astronomer Richard Carrington was sitting at his telescope, doing what he did almost every morning, sketching the spots on the surface of the sun. The activity was so boring that most of his colleagues had long given it up. Nothing ever happened. A spot here, a spot there. Make your sketch and go have some tea. On the morning of September 1st, Carrington saw a white flash. Bright, unnaturally bright. He hadn't seen anything like it in 15 years of observations. For a moment, he thought that a sunbeam from some mirror outside had hit his optics. He ran outside, no mirror. He came back, and the flash was already fading. He didn't know that he had just become the first person to witness a solar superstorm with his own eyes. 17 hours later, a stream of charged particles hit the Earth, what scientists now call a coronal mass ejection. Imagine the sun giving a cough. And that cough is a cloud of plasma that weighs billions of times more than all the airplanes, ships, and cars on Earth combined. That kind of mass was heading toward us at a speed of 3,000 kilometers per second. Auroras were visible in Havana, Cuba, and in Bogota, Colombia. People in the Caribbean islands woke up in the middle of the night thinking that dawn had begun and went to work. In the mountains of Colorado, prospectors woke up at 4 a.m. and started making breakfast. The sky was that bright. Telegraph operators around the world disconnected the batteries from their devices to protect the equipment. The devices kept working. The atmospheric current was so powerful that the wires became antennas, drawing energy straight from the air. Several operators suffered serious burns. It sounds like an exciting story from the past. But now think about something else. In 1859, there wasn't a single satellite or power plant on Earth. No internet, no banking servers, no water supply management systems, no hospitals where every ventilator runs on electricity. NASA estimates the probability of a Carrington-level storm in the next 10 years at about 10 to 12%. That's not a small number. It's about the same chance you'd get a failing grade on an exam if you showed up completely unprepared. What will happen? Major transformers around the world will fail. This isn't a light bulb you can replace in 5 minutes. Manufacturing one of these transformers takes from 1 to 3 years. It weighs several hundred tons, and there are virtually no spare units like these in any country. According to the U.S. National Academy of Sciences, the damage from a single event of this scale is about $2 trillion. That's just for the American economy. Recovery will take at least 4 years. A solar storm doesn't kill you instantly. It just turns off the lights, cuts off the water, and stops food deliveries to stores. And no one comes to help because your neighbors are in the same situation. Everyone is. Magnetic poles. Take a compass. The needle points north. Every school kid knows that, and it's worked for thousands of years. Sailors crossed oceans relying on this simple fact. But here's the thing. North isn't where you think it is anymore. The Earth's magnetic pole is constantly moving. It used to happen slowly, about 10 to 15 kilometers a year, almost unnoticeable. But in 1990, something happened. The speed increased 4 times. Now the pole is moving at a speed of 55 kilometers a year, and it hasn't stopped for 30 years. During this time, it has shifted more than it did in the previous 1.5 centuries. Scientists say this is because of changes in the liquid iron deep in the Earth's core. At 3,000 kilometers deep into the planet, molten metal flows. It's like thick jelly, only very hot. These flows create the magnetic field. The flows change. The field changes with them. Okay, so what? Well, the pole moves, fine, they'll update the maps. That's it. The magnetic field is Earth's shield from the solar wind. A constant stream of charged particles from the sun hits our planet every second. Without the shield, these particles would simply blow the atmosphere into space like wind blows away smoke. That's exactly how Mars lost its oceans 3 billion years ago. Its field disappeared. The atmosphere followed. Now it's minus 60 there, and there's nothing to breathe. Over the past 150 years, Earth's field has weakened by about 10%. That's on average. The magnetic field over the South Atlantic, above Brazil and Argentina, has weakened by a third. Scientists call this the South Atlantic anomaly. In this zone, satellites regularly malfunction. The electronics on board fail for no apparent reason. Cosmonauts on the ISS turn off their computers when passing through this zone, because radiation penetrates the shielding even in orbit. Geologists know how to read the history of the magnetic field directly in the rock. When lava solidifies, tiny iron particles in it align themselves with the magnetic field, like billions of little compass needles. Scientists have studied rocks that are hundreds of millions of years old and discovered that the poles have flipped hundreds of times. North became south, and south became north. The last time this happened was about 780,000 years ago. During the process, the field first becomes very weak, and the planet is left without a shield for several hundred years. No one knows if such a process is happening right now. Maybe it's just a normal fluctuation. But what we see in the data, the acceleration, the weakening, the expansion of anomalous zones, is exactly what preceded previous reversals in geological history. The next threat is of a different kind. It doesn't come from space or from underground. It lives in the water. And it's exactly this that determines whether there will be food on your table in 20 years. The Atlantic Ocean Conveyor. Somewhere in the Atlantic Ocean right now, a huge mass of water is moving. It's going from the tropics to the north, slowly, just a few centimeters per second. But there's so much of it that by volume, it's 100 times more powerful than the Amazon River. This current has been running for over 10,000 years without stopping. It's this current that makes Western Europe suitable for living. London and Moscow are roughly at the same latitude. But in London, it's plus 5 degrees Celsius in winter, while in Moscow it's minus 20 degrees Celsius. This difference is the warmth the current brings to Europe's shores from the tropics. Take away this current, and in a few decades, the climate of the United Kingdom will become similar to that of southern Canada. Norway will become like Alaska. But that's not all. This same current affects the monsoons in India, the rains that the harvest feeding 1.5 billion people depends on. It controls rainfall in Brazil, home to the world's largest soy and beef production, all from a single Atlantic water movement. And what ends up on store shelves on 3 continents depends on it. In 2021, a group of climatologists published a study in the journal Nature Climate Change. They spent several years reconstructing the history of this current by analyzing marine sediments, tree rings, and Greenland ice cores. The conclusion was calm in form, but terrifying in content. This current is now weaker than at any other time in at least the last 1,000 years. The official scientific view is it's not critical yet. It's still working, although more slowly. But computer models give an unpleasant range of forecasts. Some show that if the trend continues, the current could slow down significantly as early as this century. And geological data from the past shows that when this current slowed down sharply before, Europe's climate changed not over 1,000 years, but within decades. Imagine it differently. You live in an apartment that has heating. It's been working your whole life, your parents' and grandparents' whole lives. You've never thought about it. It's just there. And then the engineers say, the system is weakening. Maybe it will recover, or maybe at some point it will just shut off. And it will be impossible to restore it. Because it's not a pipe that can be replaced in a week. This is also a kind of heating only for entire continents. And there is no button to turn it back on. One more detail that makes this real. In 2010, there was an especially cold summer in Europe. Abnormally cold. The grain harvest in several countries dropped. Scientists later linked this to a temporary weakening of the current. Just one season of slight weakening, and it's already noticeable. Now imagine this not as a temporary glitch, but as a gradual years-long process. Year after year, a little colder. Year after year, a little less rain in India. Year after year, a slightly smaller harvest in Brazil. Separately, nothing terrible. Together, over decades. And then we'll be facing a completely different story.
Supervolcano.
Yellowstone. Every year, 4 million people visit Yellowstone National Park in the United States. They look at geysers, hot springs, boiling mud, and take photos. None of them think about what exactly is beneath their feet. Beneath Yellowstone, there is a huge chamber filled with molten rock. It's about 80 kilometers long and 50 kilometers wide. If you poured all that volume into standard swimming pools, you would need 160 million pools. That's exactly why there are geysers there. The ground is literally boiling from below. Yellowstone has erupted 3 times, 2 million years ago then again, and then 640,000 years ago. If you look at the intervals between eruptions, the next one is theoretically already 40,000 years overdue. Geology doesn't work like a bus schedule, so it's not a death sentence, but there's no reason to relax either. In the event of a full eruption, ash would cover most of North America in just a few hours. 1,000 kilometers from Yellowstone, ash would be half a meter thick, killing crops, contaminating water, halting transport, and grounding aviation. Airplane engines can't handle ash clouds. A small Icelandic volcano already demonstrated this in 2010 when it paralyzed all European aviation for several weeks. But Yellowstone is 1,000 times more powerful. But the main thing isn't the explosion itself. The main thing is what happens afterward. Billions of tons of ash in the atmosphere block sunlight. The temperature on the planet drops. Not everywhere, and not all the time. For years, crops will vanish worldwide. Hunger won't begin in America, where the volcano erupted, but in Africa, Asia, and Latin America, where reserves are low. Yellowstone isn't the only volcano like this. There are about 20 similar sites on Earth. The Phlegraean Fields in Italy, right under Naples. A city with 3 million residents, the Toba volcano in Indonesia. Its eruption. 74,000 years ago, according to some sources, reduced the human population to just a few thousand people. Our species literally almost disappeared. Scientists estimate the chance of a major Yellowstone eruption in the next 100 years is a fraction of a percent. That's honest and likely true. But before the eruption of Mount Pinatubo in the Philippines, in 1991, scientists were saying the same thing. A week before, it spewed 10 cubic kilometers of ash into the atmosphere and lowered the global temperature by 0.5 degrees for 2 years. Fractions of a percent are still not zero. And the last detail worth keeping in mind, the Toba volcano in Indonesia. Its eruption 74,000 years ago, according to some sources, reduced the human population on the planet to just a few thousand people. We literally almost ceased to exist. That's exactly why all people on Earth are so genetically similar. We're all descendants of that small group of survivors. Every time you think something like that can't happen again, remember that it has already happened once. The next threat, the only one on our list that we can't do anything about, absolutely nothing. It will come without warning, and we'll have 0 seconds to react. Mysterious holes in Yamal. Alexander Eisman, a geologist from Novosibirsk. In 2014, herders from Yamal called him and said they had found a hole in the tundra. He thought they were exaggerating. He flew there and couldn't believe his eyes. A perfectly round pit, 30 meters in diameter, more than 70 meters deep. The edges were turned outward, as if the ground had exploded from the inside. There were no traces of meteorites and no military facilities nearby, just a hole. He went down inside. The air there was saturated with methane, hundreds of times above normal. It became clear what had happened. Gas accumulated under the surface under enormous pressure, and then it burst out, like a cork from a bottle of champagne. Only instead of a cork, it was earth weighing several thousand tons. Where did the gas come from? All of Siberia is permafrost. The ground there hasn't thawed for thousands of years. It contains the remains of everything that once lived there. Grass, trees, mammoths. None of it decays as long as it's cold. But when the ground starts to warm up, it begins to decompose and releases methane. A lot of methane. Methane, as a greenhouse gas, is about 80 times more powerful than CO2. And the area of permafrost on the planet is larger than Russia and the United States combined. It contains 3 times more carbon than humanity has released into the atmosphere during the entire Industrial Revolution. If it starts to thaw quickly, the climate will begin to warm even faster, which will cause even more permafrost to thaw, and so on in a cycle. Since that first crater in Yamal, several dozen similar ones have already been found. Scientists are monitoring hundreds of places from satellites where the ground is starting to swell. In 2023, NASA reported that permafrost is thawing faster than predicted, decades earlier than calculations expected. This doesn't mean a catastrophe today, but it means the process is happening faster than we thought. Alexander Eisman says that after that first hole, his understanding of the tundra changed. Before, it just seemed like frozen ground to him. Now he sees it as a storehouse starting to open from within. The Yamal crater is already visible today, but there's a much less obvious and much larger process occurring. Thousands of lakes in the Arctic tundra are starting to bubble. Gas is coming up from the bottom. Scientists ride boats and set these bubbles on fire, and pillars of fire flare up over the lakes. This is not a special effect. This is methane that is simply coming out of the bottom silt. At the same time, the permafrost itself is also destroying infrastructure. Houses, pipelines, and airports in Siberia and Alaska are built on it. When it starts to melt, buildings begin to sink and tilt. In several Russian Arctic cities, you can already see this with the naked eye. The buildings are crooked. This isn't happening over thousands of years. It's happening over decades. There's something else in this permafrost, something alive, something we've never seen before. And in 2016, it came out. It woke up in Siberia. In the summer of 2016, a boy died in Yamal. He was 12 years old, anthrax, a disease that hadn't been seen in this region since 1940. It hadn't been here for years, and suddenly it appeared again. Several dozen more people got sick. Thousands of reindeer died. What happened? That summer was unusually hot. In one place, the permafrost thawed deeper than usual, and the carcass of a reindeer that had been buried in the ground since 1941 was exposed. The anthrax bacteria in it had been alive for 75,000 years. Permafrost is the perfect preservative. The temperature is around zero. There's no oxygen. There's no light. Some microbes don't just survive in such conditions. They can come back to life after thousands of years. In 2015, French scientists extracted a 30,000-year-old virus from Siberian ice. They placed it in laboratory conditions, and it came back to life and started to reproduce. Before that, it had just been waiting for 30,000 years. That virus only infects single-celled amoebas, not humans. But in the permafrost lie the remains of mammoths, woolly rhinoceroses, and the first humans. They all suffered from diseases that no longer exist today. We have no immunity to them. We've never encountered them before. We didn't evolve alongside them. At the same time, humanity is now actively developing the Arctic. We're building roads, drilling wells, and extracting oil. Every drilling rig is an intrusion into the frozen layer that hasn't been touched for thousands of years. Every hot summer means a few more centimeters of thawed ground. Every centimeter is another layer of what's inside. At the same time, virologists are talking about another scenario. In history, pandemics almost always started with a single contact. A human and an animal that had never met before. Ebola from bats in the tropical forest. SARS from the markets of southern China. The Spanish flu of 1918 killed more people than all of World War I. It took between 50 and 100 million lives in about 2 years. And every time at first people thought it was somewhere far away, that it definitely wouldn't affect us. Virologists try to anticipate and be prepared for what will happen if a disease ever appears. A disease with the lethality of Ebola, a death rate of 1 in every 2 or 3 people on the planet, but transmitted by airborne droplets like the flu. Ebola doesn't spread far because it kills its host too quickly, but viruses are constantly mutating. In one sick person, the virus divides trillions of times a day. Most mutations are dead ends, but 1 in a million can turn out to be different. This is not science fiction. It was exactly this kind of mutation that scientists were tracking in 2012 when a modified bird flu virus was created in a laboratory, one capable of being transmitted by airborne droplets. Several governments blocked the study's publication. They considered it too dangerous for open access. This means that the line between the impossible and what has already happened is thinner than we think. Did you know about this 30,000-year-old virus that scientists actually revived? And where did it go after that? Write in the comments. The next story is about 225,000 people who died in just a few hours, and about why something similar could happen again on a much larger scale. The power of water. On December 26, 2004, thousands of tourists on the beaches of Thailand noticed that the sea began to recede from the shore. It wasn't like a normal low tide, but much faster and much farther, exposing hundreds of meters of the seafloor with fish flopping on the open sand. And the people who went to watch this spectacle had about 10 minutes. An earthquake occurred under the Indian Ocean, which literally thrust a piece of the seafloor upward. All the water above it was hit from below, like water in a bucket that suddenly pushed, and that water rushed toward the shores. 225,000 people died in 14 countries within a few hours. Near the Canary Islands in the Atlantic, there is a volcano on the island of La Palma. Geologists have long considered parts of its slope unstable. If this area collapses into the ocean, calculations show that the wave reaching the east coast of the U.S. in about 8 hours would be as tall as a 14-story apartment building. And New York, Miami, and Washington are located on a completely flat coast, literally at sea level. Scientists debate how realistic such a scenario is, and many believe that the most frightening calculations are exaggerated. Maybe so, but in 2021, there was a real eruption on La Palma that lasted almost 3 months. And during all this time, geophysicists around the world were literally glued to their seismic sensors. The western slope held, but for 3 months they watched it with grave concern. There was no tsunami warning system in the Indian Ocean at all before 2004. It just never occurred to anyone that it was needed, and it was created only after the disaster. Today, it exists. But even with a warning, a person on the shore has only a few minutes, and only if there is somewhere to run. In 2004, some shores didn't even get that. Japan is the only country that, after the 2011 tsunami when almost 20,000 people died, built protective walls along 400 kilometers of coastline, up to 15 meters high. It was the most expensive construction project in history. When journalists asked local residents if this protects them, many answered honestly, "If the wave is higher than the wall, we simply won't be here. The wall only gives us time to escape, nothing more." The rest of the world hasn't built anything like this. It's important to understand that a tsunami kills not only with water. It carries with it everything that was on the shore. Cars, trees, pieces of houses, all of these turn into battering rams in the water. In 2004, there were stretches of coastline where, after the water receded, absolutely nothing was left. No trees, no foundations, just bare ground. And that was a relatively small wave by historical standards. The most powerful tsunami in recorded history reached a height of about 50 meters and moved at the speed of a jet plane. A very fragile world. On August 14th, 2003 at 4 p.m. in the state of Ohio, one wire touched a tree branch that should have been trimmed a long time ago. The automatic protection system should have responded instantly, but it didn't work because of a bug in the program. Every second, 38 power plants shut down, leaving 55 million people without electricity in 8 U.S. states and 2 Canadian provinces. Modern civilization is set up so that the power grid supplies the pumping stations, which move the water, which cools the nuclear reactors, which in turn provide electricity to the grid again. And all of this is controlled through the internet, which runs on servers that are also powered by electricity. And when one piece of this chain fails, the load instantly jumps to the neighboring ones. Those get overloaded and also start to fail. And in 2003, this wave of outages swept through 8 states in 8 seconds. Since then, this interconnection has only grown stronger. In 2021, one engineer changed a single parameter in the settings of an internet router, and Facebook, WhatsApp, and Instagram disappeared for 2 billion users for 6 hours. Not because of hackers or an attack, just a single line of code with a mistake. In the same year, hackers got into the control system of a water treatment plant in Florida to increase the level of lye in the drinking water to deadly levels. The operator noticed it by chance, just looking at the screen at the right moment. The main paradox is that as infrastructure gets smarter and more precise, it also becomes more fragile. The power grids of the 1950s were inefficient and wasteful, but at least they didn't go down completely because of a single untrimmed branch, because they were simple and had a lot of extra non-optimal connections. Modern systems are optimized down to the last millimeter. They took out everything unnecessary, so now there's no safety margin. It's like a rope with strands removed to save weight. Thinner, but it breaks sooner. And no one knows exactly where in this huge network the next breaking point is right now. It exists, it just hasn't triggered yet. Here's another telling example. In May 2021, hackers attacked Colonial Pipeline, a company that pumps gasoline through pipelines across half of the eastern states of the U.S. A few hours after the attack, the company itself shut down the entire pipeline.
Чтобы вирус не распространился дальше.
Gasoline disappeared from gas stations in 6 states. People lined up and bought fuel in any container they could find. In some cities, gas stations stood empty for 5 days. All of this happened because of a single successful hacker attack on one company. This isn't a theory about a distant future. This is 2021. This happened in the world's most technologically advanced country. If you think that systems have become better protected since then, in 2023 there were 3 times as many similar attacks on infrastructure as in 2021. Where did the bees go? In 2006, American beekeepers started finding empty hives. Not dead bees, but empty hives. The bees simply disappeared, leaving behind neither bodies nor traces. The hives have honey, larvae, and a queen, but no worker bees. It's like they left one morning and never returned. Within a single season, between 25 and 40% of all bee colonies in the U.S. disappeared. Scientists called this colony collapse, and they admitted that they didn't understand the cause. It's been almost 20 years since then, and the situation hasn't improved. Every winter, American beekeepers lose an average of 30 to 40% of their hives. The numbers are similar in Europe. In some regions of China, bees have disappeared so massively that farmers pollinate fruit trees by hand, using small brushes, flower by flower. This is happening right now, not in theory. Why is this important? 1/3 of all the food humans eat depends on pollination by insects. From cucumbers to strawberries, coffee, and sunflowers, all of these require pollinators. Almonds in California, used globally in chocolate, and milk rely almost entirely on bees for pollination. Each spring, around 2 million bee colonies are brought in from across the country due to a shortage of local bees. There are several reasons for this, and scientists argue about which one is the main reason. Pesticides, which don't act immediately but accumulate over time. The varroa mite, which parasitizes bees and weakens their immune system. Loss of plant diversity. Now every flower sees monoculture fields of a single species around it. Viruses. Climate change, which shifts the timing of blooming so that bees wake up earlier or later than the flowers. Most likely, it's all of these factors together. The strangest thing about this story is that bees have existed for about 100 million years. They survived the asteroid impact that killed the dinosaurs. They survived all the ice ages. But in the last 20 years, their population in different countries has decreased so much that people have started pollinating plants by hand. This is the first time in history that humanity has seriously thought about how to replace an insect. And so far, there is no answer. There's something else. Wild bees, not the ones kept in apiaries, but the wild ones that live in burrows and crevices, are suffering even more than domestic bees. It's just that no one counts them as carefully. And it's these bees that pollinate wild plants which sustain ecosystems. When wild plants disappear, the animals that feed on them disappear as well. When these animals disappear, the next link in the chain collapses. We're used to thinking about ecology,
О чем-то далеком и абстрактном.
but in reality it's held together by specific little creatures that fly between flowers every day. Take them away, and in a few years, store shelves will start to look completely different. There are several million species of creatures living on this planet, and only one of them knows about what we discussed today. Only one can analyze data from rocks, understand what's happening with the magnetic field, count the bees, measure the temperatures of currents, and draw conclusions from all of this. No other species knows what threatens it.
И просто живут, пока могут.
We know. This is either our main advantage or the greatest responsibility in the history of life on this planet. Most likely it's both at the same time. Subscribe to the channel. Every week there's something new here that makes you see familiar things in a completely different way. And write in the comments which threat from this video scared you the most. Thank you for watching. Goodbye, everyone.